Dr. Rao and Karthik for sponsoring and mentoring both Paul and me this summer. And with that, let's begin. Paul's demo will use Python to interface between the planner and robot in order to get the robot to the front of the lab. I'll explain exactly what's going on as the video progresses. So here you can see the robot starting up. That just happens by executing the code. The code will automatically start the robot and initialize the planner. So the first thing the robot does after it gets up is it centers itself on the now marks. The now marks are what it will use to basically establish its path and find out where it is in the lab. So basically right here, the robot is using transforms in order to locate where the now mark is in its camera space and center its position and its angle on the now mark. The problem with this is that when centering its position, because the robot has a slight tilt in its walk, it doesn't always center perfectly, and that's why the angle change is necessary in order to get that centering near perfect. So right there you saw the robot turn 90 degrees. That happened because it detected the now mark. It detected it was close enough to the now mark that it could get into the next area and turn left into the next area. It then updated the planner and told it that it was in that new area, which it just did again. And once it tells it that it's in a new area, it replans and spits out a new plan, which the robot then executes. So there you saw that happen twice in quick succession. The first time when it saw the now mark attached to the fan, and the second time when it saw the now mark that was hanging from the ceiling. That let it know that it was first in the right hall and then in the middle of the right hall. So this is the more boring part of the video. Here the robot is essentially walking straight inside the middle of the right hallway segment. It's going to continue doing this until it reaches the front of the right hallway segment, which is its final goal. So there you can see the now mark that's hanging on that desk. That is the front of the right hallway now mark. Once the robot gets close enough to it, it will recognize that it's in the front of the right hallway and terminate the program. So here you can see the robot's pretty on track to reaching the now mark just fine, but for some reason, right here it starts to realign itself and tries to center itself on the now mark, even though it was basically already centered on the now mark. The big problem here was that it was a pretty significant change in X, which because of the tilt leads to a pretty significant change in Y. So when it tilts that angle, it actually completely almost loses sight of the now mark. Luckily, it stays inside of the now mark, which allows it to realize that the now mark is not centered and adjust again. So here it adjusts again, and once it realizes it's on path again, starts walking towards the now mark. Here it detects the now mark, and as the goal is achieved, we terminate the program. Alright, as for my demo, I did mine in Java to essentially have it detect all the now marks that were located in the room. So basically what it does is it will start at one now mark, and every time it sees a new now mark, it will head toward it until there are no more new now marks to be detected. So here the program loads up and it starts walking towards the first now mark. There it says that it has detected the now mark and turns into the next hallway. The planner is updated and it receives and executes the new instructions. Here it takes a step into the new hallway. So here the robot has detected the new now mark and will start walking toward it. What it does when it detects the new now mark is it actually updates the planner with a new area. So originally the only area that the robot knew about was that very first now mark, the top of the right hallway. So here it physically adds new code to the planner file and then updates the planner and re-executes instructions. So here it found this now mark that you see, and it stepped forward into the area, and now it's looking for another one. It didn't detect one right away, so it's spinning in a 360 to see if it can find a now mark that it hasn't seen before. So when the robot stops like that and starts walking forward, that means it's detected a new now mark. So it just walks forward so that it can get a closer look at it and make sure that one, it is indeed a new now mark, and two, that the now mark stays in its vision. In this case, the now mark didn't stay in the robot's vision, and it performs another 360 to look for a new now mark. So in the first pass of the 360, the robot didn't see the new now mark. That's why we did 2 full passes, because with the robot's turning speed and the camera shakiness, it doesn't always see it on the first time. And here you can see it stops again and starts walking forward, which means it has detected a new now mark. And here you can see the now mark that it saw. And for a third time, it loses sight of the now mark. But it almost immediately recaptures it, finds it, and starts walking forward towards it.
I haven't found a new area. I am going to go check it out.
So here the robot officially detects the new now mark and updates the plans with the new area and receives new instructions. So there, the robot, because it was so close to the now mark when it found it, it almost immediately recognized that it was at the end of the area and updated the planner saying it had reached the end of the area. So that 6 steps you just saw going forward was it stepping into the area and looking for a new now mark. So right there, it saw the new now mark, updated the planner with the new now mark, and received new instructions. So after receiving those new instructions, it walked towards the now mark. It saw it again. It saw that it was close enough to it, so that it updates the planner saying that it has reached the end of the area, and it's now looking for a final area. However, since this is the last now mark that we wanted it to detect, it has reached the final area. If it sees another now mark, that means that something is wrong with the program. If it doesn't, that means that the program is executed as it was expected to, and the program will terminate. So this is just a bit of code dump. This is the original PDDL file. These are the updates that were sent throughout the program, and this is what the final PDDL looks like. As you can see, there are new areas and new connections, as well as a change in the goal. So the key differences between the demos were the languages used, the initial objects and locations, how the updates were formatted, and the way that now marks were detected. So once again, I'd like to thank you for supporting us this summer, and we look forward to continue working with you.